All right, so now we are going to move on to multivariate regression. And for this, I'm going to revisit an example that I had proposed a couple of weeks ago that, let's say we're wanting to assess the impact on how much, let's say that we're wanting to address the argument that people make about, you always say that there's a link between if you're exercising and how happy you are. And maybe it's not the exercise. Maybe it's that people who exercise obviously have the free time every week to exercise. So let's say that we're wanting to look at a regression model where we're going to consider 3 different variables and how they work together to impact happiness. Now, before we move forward, I want to point out that this is the key difference in doing a regression model and in doing a correlation. Because with a correlation, right, I can make that big correlation matrix, like what we talked about in the last chapter, and I can say, okay, free time is correlated with happiness this way. Average sleep is correlated with happiness this way. Exercise is correlated with happiness this way. But that's all I have, is those individual things. And sure, I could add them up and make some combined variable of, free time plus exercise and all that. But I'm not truly capturing how are these working together to impact it. And are they working together? And if I consider all of them together, are they all 3 significant? Or are some of them taking away the significance? Because one of the things that we're doing in regression when we're considering multiple independent variables at the same time, let me see if I can think of a way to draw this out that will make sense. So let's say that I have, so if we're coming over here and wanting to look at happiness, let's say I have free time here, okay? And I'm saying, here's how free time is impacting happiness. But let's say I throw in average sleep, right? Because I'm proposing if you have more free time, you can get stuff done. You might not have to stay up late at night getting stuff done. And you have the ability to say, you know what, it's been a long day. I'm going to bed at 9:30. I don't care, right? So let's say that when we actually put our data in, one of the things that we find is because of that overlap of the way that your free time is related to how much sleep you get, there are statistical methods, and again, going into how it actually does this is way beyond the scope of this class. Just understand there's statistical methods that do it. There are methods that your software is going to be able to compute behind the scenes that is going to be able to assess, okay, there is a section of overlap that when I look at the way that free time is impacting happiness, it's not over here completely separate from the way that sleep is impacting happiness. Let's say this was free time and this was sleep. They're not over here floating around as these 2 totally separate entities that don't have any relationship with each other. What you would do is you would look at this and you would be computing that there is an amount to which the way that your amount of free time and the way that your amount of sleep are related. And that relationship is kind of working in the same way in terms of how it's impacting happiness. There's this shared variation between the 2 that's affecting happiness. And so what this type of regression analysis we're going to talk about. Now, if you get some more advanced software, I believe the new pack of SPSS can do this now. And if you do modeling and stuff in Amos and other, none of this means anything to you. Know that there's some advanced statistical techniques that can do this in a different way. But for what we're talking about in this class, the way that I'm going to show you a multivariate regression analysis, what's going to happen here is your software is going to look at this shared impact, the way that these 2 are similarly impacting happiness, and go, you know what? This doesn't count. None of that counts. And so now you're going to have to assess if free time is still significant without that, and if sleep is still significant without that. Because we've said that that section where they were overlapping, that no longer counts. We've made them be separate entities. We've taken away some of their effect. And sometimes this will matter more than others. Because remember the argument that I was basing this off of, that I had proposed a couple of weeks ago, that there's more and more people who are saying, maybe we shouldn't just be looking at the impact of exercise. Maybe we should be considering all of the things that could play into that, with maybe they're getting more sleep, so they wake up with more energy, and so they feel like exercising. Maybe the real relationship here is with sleep, or maybe they have more free time, so they have time to exercise. So the real relationship here is with free time. And so those are the things we're wanting to assess, because the way that we can look at that is to say, if I look at free time, if I look at exercise, and it is statistically significant. So let's just consider exercise right now. If I look at exercise and it is statistically significant, exercise is impacting happiness, and I throw free time in there, and it's also significant, and exercise remains significant, I know that to an extent, these are two separate entities. It's not that one of them is explaining the other one. It's that these are both working to impact happiness separately. Now, if I look at this and I say, okay, exercise had a statistically significant effect, but then I throw in free time, and it ends up being something like this, okay? None of this impact of exercise right here counts anymore. This all goes away from the analysis. And if exercise is no longer statistically significant, what does that mean? That means that the relationship of free time is what's more important. It is bigger. The way that free time was related to exercise, with them working together to impact happiness, that pretty much absorbed the entire effect of exercise, right? And so this is no longer significant. And I'll show you an example of that in the data. But so this is an important thing to realize about regression, is we're not just going to be able to look at this and say, oh, hey, I did a correlation matrix, and all three of these things were significantly correlated with happiness. Therefore, I can do a regression model, and all of these variables will be significant in my regression model. It might work out that way, but if suddenly you see that one of these is not significant in your regression model, you're going to have other things to look at to try to determine, all right, so the effects of one of these is overshadowing the effects of another. And I'm going to show you how to do that. What I referred to earlier is there are some statistical techniques that are really interesting. They would just be beyond the scope of what we're doing in this unit, where you can actually tell your software, you can control it more, and you can tell your software, no, I am putting this variable in. You keep the effect of this variable if it's statistically significant. Don't throw it away. And then when I come in and add this other variable, free time, you let it have the leftover effects that have now already been claimed by this one. And that's how I can say things like, free time has this much of an impact over and above the impact that we're accounting for by exercise, or vice versa. I could put free time in first, and I could say, you let it have its full effect, and then see if there's any effect left over for exercise at the end. And if there's not, then again, that would give you your answer of once you've accounted for someone's free time, exercise does not have much of an effect above and beyond that. Or if it still did, then you would know you had two significant variables. Again, we're not going to do that. I just want you to know that type of math does exist. So if you ever see an article that references that and uses that language of over and above when the effect of this was controlled for, that's what we're getting at. We use that a lot. If you start to getting into some more advanced research data analysis, it's used a lot. But I just wanted you to be aware of that language if you end up seeing it at all with the literature review you're going to do for your final paper and all that, so you know what it's talking about. And a lot of times that'll start referring to language like stepwise and listwise and all of this. If you run into an article for your final paper that you're just really having a hard time understanding the language that they use, if it's a regression, let me know and I can help you out, or I can say this is super complex, you might want to pick a different article. But just so you know, that is an option for regression, just not one we're going to do right now. So back to this example. Where are we? Multivariate regression. We're considering multiple variables at a time, multiple predictor variables, multiple independent variables, and their effect on a dependent variable of interest. The betas of these scores are going to be lower than their correlation values because, again, or most of the time, they're going to be lower than their correlation values because we are removing any shared impact that those two variables have. We're making them operate as their own independent entities. So I'm going to show you how to look at that and how to assess for that. Now, in your output, one thing to be aware of is you will see an R value and you will see an R squared value. Before we actually get into the output, I want you to know going into it, your R squared is the percentage of the variance in this score that we can account for, that we can predict when we consider all of these variables together. So like in this, if my R squared ended up being 0.3, what I could say is I can account for 30% of the variation in my happiness scores by looking at the combined impact of these three data points. Okay. Now the effect size of that, let me write this down for you. Kind of like with correlations, we have our effect size to determine is this a small, medium, or large effect. So 0.02 is small, 0.13 to 0.25 is medium or moderate. So medium or moderate. And 0.26 and higher is high or strong. Okay? So your markers for this one are 0.02, 0.13, and 0.26 as we're assessing the impact of what percentage of variance accounted for is actually considered good or is considered strong. Okay. So what we're going to do now is we're going to switch over to Pspp. I have built a data set, and we're going to look at how this actually looks when you're analyzing it. Because like I said, I don't care if you can do this by hand. I care about you being able to put your numbers in, know where to click in the software, being able to get your output, and being able to turn the numbers in your output into words that you can use of, this tells me that this is how this is influencing this. That is what I care about. Okay, so make sure you understand all of this background stuff before we get into Pspp, or once we get into the output, you're going to get really lost really quickly. Okay, because this can start to get a little bit more complicated. So if you need to rewatch these, rewatch them before moving on to the Pspp part.